Well, hello. Today we are going to finish up our chapter 4, and we're going to be looking at circles. We're going to look at circumference and area of circles. We'll look at when you take a circle three-dimensional, it becomes a sphere. We'll talk about that. And of course, cylinders and then something called composite figures. Now, composite figures just means they're made up of several different shapes. Okay, so we're going to be measuring them, finding volume and surface area. So we're going to start out with circles specifically in this section. And when we talk about the circumference of a circle, that means to go around the outside. That's what circumference means. It means to go around the outside, measure in a linear distance around the outside of a circle. And the value of pi, this is a number most people have heard of. A lot of people think it's exactly 3.14. It's a very famous number. It's not exactly 3.14. It's actually said to be irrational. It'll be like 3.1415926. I don't know. That's all I know off the top of my head. But you can Google it and find like the 10 millionth digit of pi. It keeps going on forever and ever, doesn't repeat. Notice these are approximations. Some people like to use this. I don't like to use this one, but 22/7 is about what pi is. Pi is not 22/7. Pi cannot be written as a fraction. This is just a fraction that is very close to what pi is. Okay. Pi is just a Greek letter, and they just use it for a constant because it's a very famous and very useful constant. Now, when we talk about the circumference of a circle, we can see that the circumference of a circle, C, the circumference is pi times diameter. Okay? You probably want to memorize this, pi times diameter. See, that means that if you have a diameter, if I were to take this and like measure a string out that long, I could take that string and I could press it up along the outside of this circle once, twice, 3 times, and then I'd still have a little bit left over. Because remember, pi is 3.14, 3 whole times with a little bit more left over. And so the circumference is going to be 3 whole diameters along with 0.14 of a diameter, so a little bit more left over. Okay? So a diameter would fit around our circle 3 whole times with a little left over. Now the other formula that you'll use a lot with this circumference is this one right here, which says 2 pi r. A radius is half of a diameter, and that's why you just take 2 times the radius, and that'll get you the diameter. So a little more than 6 radii would fit around a circle. So if we look at our example here, we've got in this particular circle, you can see that the radius, let me make that a little bigger in case you can't see it. The radius is 6 inches, and it wants to know the circumference of the circle, meaning to go all the way around the circle. All we're going to do is plug those numbers in. We get 2 pi r, because we have a radius. So we have 2 times pi times 6. That gets us 2 times 3.14 times 6, or about 37.68. Now, the diameter of a car tire is 16 inches. So I think that's a pretty small car tire. But, you know, maybe it's a small car. So notice they give us the diameter. Just a minute ago, I worked this problem off camera, and I actually didn't notice that it said diameter, and I counted it as a radius, and I got the wrong answer, and I was like, what's going on? Well, it's because I didn't read it carefully. The diameter is 16 inches. So our circumference is going to be pi times 16. Or we're going to use 3.14 and multiply that times 16. Okay? So let's go ahead and do that. We'll do one of them by hand. I'm going to use calculators a lot on this. But we can do some of these by hand. So we'll take this, 4, 2. If you need some practice with multiplication, it's a good idea to get this practice in. If you're really good at multiplication, you just want to get the homework done, or just make sure you understand the concepts. Using a calculator is a great way of making sure you understand concepts and you're doing the math correctly. I know that should be 50.24, so obviously I did not do the math correctly because I was talking to you. This is the one that's not right. Maybe I should do less talking. Wait, that's why I'm here, though. Oh, what a conundrum. All right, so that's better. Now we get this, 50.24. See, I do this enough that I know that I actually have that one memorized. It should be 50.24. That's how I knew I had it wrong. Okay, so the circumference of this circle is 50.24 inches. Now, that's just one circle. This says the tire makes 2 complete revolutions. The tire's going to roll 2 times. How far will it travel? So all we're going to do is take 50.24 and we'll take that times 2. That's going to get us 100.48. So we have 100.48 inches. That's how far this goes. It says find the circumference of a circle with a radius of 18 inches. So once again, we have a circle. We have a radius of 18 inches. And then we're going to go around that. So like that, okay? So the circumference, we know that we're going to use 2 pi r for our circumference this time. That's because we have a radius, not a diameter. We have a radius. So this is going to be 2 times 3.14 times the radius of 18. Now, one thing I like to do is I actually would multiply these two together first. The reason I do that is because sometimes, those would multiply to be 36, and sometimes people will actually leave an answer. It's said in terms of pi. Just means you don't got to worry about multiplying times 3.14. Now, in this case, it says use 3.14 for pi, so I'm going to actually multiply 36 times 3.14. Be careful because some calculators have a pi button on it, and that pi button is much more accurate than 3.14. Let me show you on my calculator here. You can look right down here. I actually have a pi button. And if I take 36 times 3.14, which is what we just did, you can see I get the 113.04, like what I just had. But if I were to use that pi button and I get 36 times, and then I use the pi button, see how it even puts a little pi symbol right there. I'm actually going to get a number that's a little bit bigger. This one's 13.04, or 113.04. This one's 113.097, right? It's a little bigger. That's because there are many more decimals. This keeps going. This is using 3.1415926. I don't know, whatever it uses, many more decimals. Okay, so be careful, make sure you read the directions. This says use 3.14, so don't accidentally use the pi button. Now, for area of the circle, we're going to use this formula. This is another one that you are going to want to memorize. And notice this does not say pi times diameter. No, this is the radius squared. You have to use the radius. If you're given a diameter, cool. Cut it in half and use the radius. Because this doesn't say 2 times radius. It says radius squared. And you know, according to PEMDAS or GEMDAS or whatever you subscribe to, that you've got to do those exponents. You got to do those before we multiply with pi. All right? So a quick example that's already done for us. We can say if this one has a radius of 8 inches, then we'll do pi times 8 inches squared. Pi times 8 inches squared. Well, 8 inches squared gets us 64 square inches times pi, and now we just got to multiply that by 3.14. That's how we end up getting 200.96 square inches. All right, let's go ahead and find the area of these two circles now. Oh, God, computer, stop. All right, so the area of this circle, area is pi r squared. I know that my radius is 8 centimeters. And now I also know that I have to do the squaring first. So this will be pi times 64 square centimeters. And now I've just got to multiply that. And of course, if you were paying attention to our example that we just did up there, then you know that this is going to multiply to be 200 0.96. And then you got to pay attention to our label, though, because it is going to be square centimeters. That's something that I would absolutely take off for if I was evaluating you and you put on here inches or you put on here something that wasn't the appropriate label, right? Because that's important. It's important to know whether or not somebody owes you $200 or 200 cents. It's important to know whether your circle is 200 square centimeters or 200 square feet, because it's a big difference. Okay. Find the area of a circle with diameter of 9. Okay, diameter of 9. That means that we're going, oh man, let's just undo that and pretend like I never made it that circle. So let's make a better circle here. Hey, look how good I am at drawing circles. And then a diameter of 9. See, I can draw straight. Now, knowing that our diameter is 9 means that our radius is going to be half that. So it's 9 halves, or 4.5. Now, our area is just pi r squared, so I'll use 4.5, put that in there. I'm going to go ahead and write my centimeters in here. I understand if you don't, you just want to put it on right at the end. I'm going to put it right there, though. Okay. And then we're going to first go through and multiply 4.5 times 4.5, because we have to do that before we multiply it by pi. When you do that, you're going to get pi times 20.25. Right? If you just multiply 4.5 times 4.5, then you're going to end up getting that 20.25. Now pi, we said we're going to use 3.14. So we're going to take 3.14 times 20.25. And this is one that, again, I'm just going to do this on the calculator. When we multiply this all out, if you need practice with this multiplication, then you should do it. But you should get exactly 63.585. So that's going to be our answer for the area of this circle. Okay. Now we can take these circles and we can combine them with some other shapes as well. These are called composite figures. So you can see a shape like this, though. This looks like almost like an ellipse, but it's not. An ellipse is constantly changing, right? It's round. It's just kind of squashed down. You can see very clearly we have some straightaways. So this is more like a racetrack, right? You have straightaways here, and then over here on the side you have a semicircle, and a semicircle means half a circle, and half a circle. So this shape could be broken up like this. Okay, and that's maybe a little more useful. Okay, let's find the approximate perimeter of this figure, knowing that we're talking about shapes that aren't quite just normal circles and rectangles and stuff like that. We've got to do more stuff to them. All right. So let's start out with this part right here. Let's find that part to start with. Now, we do have to assume something. We have to assume this is a right angle. It looks like a right angle, and I'm going to go ahead and assume that it is. That means that we are doing 3/4 of a circle. Hopefully, you know, if you need to go back and maybe revisit fractions, you can, but hopefully you could all see that we could complete the circle here, and if we get rid of this part right here, we're left with 3/4 of a circle. Okay, so that's important to know. That means that we actually want 3/4 of the circumference. That's what that part will be. So let's find the circumference. Circumference is equal to 2 pi r. Remember, it's either pi times diameter or 2 pi r, or 2r pi, right? The commutative property of multiplication allows you to switch those around. So our r is going to be 4. And now we have 2 times 4 times 3.14. Okay, and you multiply that all out in, let's see, 8. I'm doing this on the calculator because I thought I had it memorized, but I just want to double check. I didn't want to put the wrong thing down. There we go. So the yellow part to this ends up being 25.12 centimeters. Now I've got to do this other part. I've got to do this part here because this is a composite figure, meaning it's made up of more than one thing. Oh, nope. I've found the whole circle. That's what I found right there. Right? Do you guys see that? Man, I'm glad I double checked. I have found the whole circle. Okay. Next, what I need to do, if I only want 3/4 of that, I'm going to take 3/4 times 25.12. Now we can go through and divide it by 4 and then multiply by 3, or you can multiply it by 0.75, whatever you want to do, but that's going to end up being 18.84. Now, that is this part, and I feel confident in saying that. So we've gone around, that's this part here. We're good. The next part that we have to do, though, is we've got to get this part here and this part here and add those together. That's pretty easy because our radius is 4. So that means this is 4 centimeters here, and this one's 4 centimeters there. So that's just going to be 8. So I'll take my 18.84, I will add on 8 centimeters. How about I line it up a little better? And that gets me 26.84 centimeters. Now that is a linear measurement. And that's the perimeter. The area is actually not so bad. The area I think is even easier because it's just 3/4 of a circle. So all I'm going to do here is find the area of a circle is pi r squared. That's going to be 3.14 times 4 squared. So I'll multiply the 4 first and get 16. And then we have 3.14 times that. And of course, this is the same one that, that we did earlier, right? That's going to get us our 50.24. And then we take that times 3/4 because we only want 3/4 of the circle. So we'll take our 50.24 times 3/4 and get 37.68. Specifically, that's 37.68. It's an area. It's square centimeters. Okay. All right, we've got 2 more problems to do in this part of the video. Here, I see that we've got a rectangle, and then what we're going to do is take this rectangle and chop out part of that, which is this circle here. So let's start out by says find the approximate perimeter and area of the figure. Okay, so let's do the perimeter first. Okay. So we've got 3, 6, right? Because, well, let's put them all on here. 3 meters there, 3 meters there. How long would it be all the way across here? It looks like it's 3, 6, 9. Here we go. And if we add up all of these black lengths around here, just the black lengths, not the red ones, we add up all the black ones, we get, let's see, 3 plus 3 plus 3 plus 3 plus 3 is 15, plus 9 makes 24. So all of the black ones combined are going to add up to be 24. 2, 3, 4, 5. Yeah. And then what we'll do is now we have to add on, oh man, nope. I did it wrong. Uh, 3, 3, 3, and 3 is only 12, plus 9 makes 21. All of the black parts add up to be 21. Now I've got to add on that circle, right? You see, I don't know if you saw what I did. I actually added 3 more in as though this were going to keep going. So that's what I did wrong. So we're going to go 3 plus 3 plus 9 plus 3 plus 3. That gets us 21. Now I've got to find the red part. And the red part is just the circumference of a circle with a diameter of 3. Okay? And we know that the circumference is equal to pi times diameter. Well, I only want half of that. Look, this isn't a whole circle, so I only want half of it. So therefore, let's cut this in half. Let's divide it by 2. So we're going to take 3 times 3.14 and then divide it by 2, and that's going to get us 4.71. Okay, so the red part of this is 4.71. That's going to get us 25.71 for the perimeter. Let me go back and double check my math here. Yeah, I think we're good with that. So we get 25.71 meters. That's a linear measurement. Now the area, again, I think the area is even a little easier because the area is just going to be the rectangle minus, and we're going to cut out that circle, right? The area of the rectangle is 3 by 9. So the area of the rectangle is 27 square meters. And then the semicircle here, well, I know the area of a circle is pi r squared. Specifically because as a semicircle, I'm going to want half of it. So I'm going to want 1/2 pi r squared. 1/2 times 3.14 times the radius. The radius is only 1.5 meters. Don't forget to square that though. And I'm going to show you how I would do this on the calculator. I would put in 1.5, and then I actually have a square button right here. It says x squared. So I would do that. And then we'll take that times 3.14. Oops, apparently my decimal didn't go. 3.14. And then we said we wanted half of that. So I'm going to take it times 1/2, or 0.5. Okay, so you could do all this by hand if you wanted. I'm just kind of expediting the process a little bit. That gets me 3.5325. Okay, and now I've just got to subtract those. 27 minus that, right? 27 minus our 3.5325. So I'm going to go back to the calculator. I'm just going to do minus 27. Now, this is going to give me a negative answer, but of course I know that I really would be doing the 27 minus this. So this will be positive 23.4675. Square meters. The last problem to look at here today is the area of the shaded portion. This is a classic math problem. Let's put a circle inside a square and find the leftovers. This is a very, very classic problem. You see, we have a diameter of 8, but in order to find the area of the circle, we need the radius. So what we're going to do is find the area of the square, and we're going to subtract off the area of the circle. The area of the square is pretty easy. That's just 8 times 8 is 64 square meters. Then the area of the circle, of course, is pi r squared. Well, if this whole side length here is 8, then the radius must only be 4. So this will be pi times 4 squared. Okay? And then we end up with 3.14 times 16. Man, that looks familiar, huh? I told you there's a reason why, as a math teacher, I have some of these memorized. It's because I use them so much. They just kind of come up, right? And you're like, you made the problems. Well, I got the problems from someone else. But you can see we just use the same problems. So we're going to be taking 64 minus, whoops, 64 minus 50.24. Okay. And when we subtract those, we end up getting 13.76 square meters. And it is area. That's how we end up getting this shaded portion. The whole square is 64 square meters. Then we have the circle we found to be 50.24 square meters, and we subtract those two to find the shaded part. Okay? All right. Well, I hope this is a little bit helpful in learning a little bit more about circles. Like I said, some people leave answers in terms of pi. If you ever see that, like the answer in terms of pi for this problem actually would just be this, and then meters squared. So if you ever see something in terms of pi, it just means don't multiply 3.14. For what we're doing, we're pretty much always going to multiply it. I'm just letting you know that sometimes you don't. So make sure you memorize the formulas for area and circumference of a circle. Don't get them mixed up. All right? Good luck with your circles.